understanding the challenge of reading weight data with the Omron CJ2M PLC is crucial. The problem lies in the limitations of the integrated port, which cannot open sockets to transmit and receive data. This means you can't directly send a request string and get a response string using the onboard port. Instead, you'll need to consider alternative methods, such as using an Ethernet card like the ETN21. This leads us to explore the possibility of using the Ethernet TCP/IP port available on the weighing terminal, which might support the Ethernet IP protocol. By obtaining the EDS file from the manufacturer, you can facilitate data exchange with the CJ2M's Ethernet IP port. This is the first step in overcoming the hurdle and achieving seamless weight data reading. Understanding why the integrated port can't be used for this specific task is crucial. The CJ2M CPU33's integrated port has a firmware limitation that prevents it from opening sockets. This means you can't send messages or read responses directly through this port. It's a restriction set by the firmware, which even the smallest CP1LE model doesn't have. This limitation is significant because it affects how you can interact with external devices, like the D70E scale in this case. If you attempt to use the integrated port, you'll find that it simply won't work for socket-based communications. This is a critical point to grasp, as it will guide your decision on which hardware to use for your project. And here's why that matters. When the integrated Ethernet port falls short, the serial port becomes your lifeline. Imagine the serial port as a robust, reliable communication channel, free from the limitations of the integrated port. To leverage this, you'll need to configure your PLC to communicate via RS-232 or RS-485, depending on your specific hardware. Set the baud rate to 9600, parity to none, data bits to 8, and stop bits to 1. This configuration ensures a stable connection. The trick is to use a protocol converter if your device doesn't natively support serial communication. This way, you can transmit your request string and receive the weight data seamlessly. Remember, the serial port offers a straightforward, no-nonsense approach to data exchange, ideal for environments where simplicity and reliability are paramount. Now, let's delve into the Ethernet option for the D70E scale. The Ethernet connection offers a robust alternative to the integrated port limitations we discussed earlier. To establish this connection, you'll need to ensure that your PLC supports Ethernet communications. Check the PLC's manual for Ethernet compatibility. Once confirmed, configure the Ethernet settings on both the PLC and the scale. Set the IP address, subnet mask, and default gateway on the scale to match your network settings. On the PLC side, use the Ethernet IP protocol to communicate with the scale. You'll need to obtain the EDS file from the scale manufacturer to facilitate this communication. This file contains essential information about the scale's Ethernet capabilities, allowing the PLC to interact with it effectively. Remember, precise configuration is crucial here. Any mismatch in settings can lead to communication failures. Let's recap the critical steps for weight reading solutions using the CJ2M CPU33 PLC. Initially, we identified the limitations of the integrated port, which cannot open sockets for communication. This led us to explore alternative solutions. We discovered that using the Ethernet port with the ETN21 card is essential for socket-based communication. Additionally, we discussed the possibility of utilizing a serial port for a custom protocol. Remember, the Ethernet IP protocol and the EDS file can facilitate data exchange if supported by the weighing terminal. This comprehensive approach ensures you have all the tools needed for effective weight reading. If you found this deep dive valuable, consider subscribing for more in-depth, free technical education.